Hello, sir.
Hello.
Hey, David. I'm going to sit in front, be with the crowd. Good to see you, David. How are you?
Hey, David. How are you?
Great, doing good. Welcome, David. We're here with the first Core Dev Bootcamp that is been going on for a few days now. We have in the room about 25 people who came from all around the world to learn about XRP Ledger, the protocol, how it was built, how it works, how to interfere with it, how to improve it. We have several teachers and tutors in the room. If you guys want to stand up, say hello. I don't know. Come in the screen. Hey.
Hi. Hello.
It's really good to see you, David, and to have the chunk of time of you. I think you always come forward when it's about the XRP Ledger, and always makes yourself available. So we really appreciate it. We're not going to go around and ask everyone to introduce themselves, but we already have a few questions. So here we're really getting to the nitty-gritty details of the XRP Ledger, and maybe you want to start and walk us through, how it was building the XRP Ledger in the early days. What was the mindset? What was the idea behind it? When did you join it? Because we saw that you were #1 contributor on the code base. Something before what? So we have a bunch of questions. But maybe we just want to start with the story, how it started, and walk us through the journey.
Sure. So for me, the journey began towards the end of 2011. Jed McCaleb had the very original idea. And at the time, because proof of work was like the biggest thing that Bitcoin does different, everybody just sort of assumed that proof of work was like the secret sauce that made Bitcoin amazing. There's still people who believe that to this day. But I think at that time, the very first sort of cracks in the veneer were starting to appear. So for example, one early idea was that everybody could sort of mine on an equal basis, and that mining would be just like a standard way to convert extra power into money. And we now know that that's economically impossible, because whoever's the most efficient at it will just sort of drive everyone out of the business. And I think it was first becoming clear that proof of work wouldn't be democratic. It would create sort of, forced stakeholders. And it was the very first beginning. And Jed had this idea that you could replace proof of work with something else. And his original idea was a distributed agreement algorithm. So many of you probably know that there's been these distributed agreement algorithms have existed for a long time in computer science, since the 70s. And he had this idea that you could use a distributed agreement algorithm instead of proof of work. And we didn't know at the time, number one, whether that would work. And number two, if it did work, whether it would be good for anything, and what way its properties would be. Would it be different than Bitcoin? Would it be strictly worse? Would it be better in some way? So I started working in November of 2011 on replacing Bitcoin's proof of work consensus with a distributed agreement algorithm. And we discovered fairly quickly that it would work. You could do it, and it would produce some different properties from Bitcoin. One big difference is the consensus could be significantly faster. And would that be interesting? We also developed an account model rather than the UTXO model, which has its advantages and disadvantages. And then we brought Arthur Brito on as we were starting to think, what would be the distinguishing feature? What was the superpower that this chain had? And our earliest idea was Bitcoin and most other blockchains today, there with very few counterexamples, they have somebody who produces each block. They have some method of deciding who produces the block. In Bitcoin, it's whoever wins the sort of proof of work lottery. In Ethereum, it's the stakers are selected in proportion to how much stake they have, but somebody is chosen, a sort of leader that gets to produce the block. And we realized even back in early 2012 that the XRP Ledger's consensus algorithm was leaderless. It didn't have somebody who produced the block. And so we thought, because we have that advantage, what is an application where you need that advantage? And Arthur mostly
realized that you could have an asset exchange, that you didn't want to have an asset exchange if you had a block producer, because the block producer could reorder transactions to their advantage. They could not, if there was some offer that was at a price that turned out to be too high or too low because the asset price moved, the person who produced the block could take that profit for themselves. They might not let you cancel an offer. They might let you place only the best offers for them and then take them and insert their own transaction to take them. So we realized in 2012 that because you could not do that, our technology was uniquely suitable for an asset exchange. And so we took some inspiration from some work that Ryan Fugger did back in 2004. We created issued assets, which were basically the first stable coins. We created the first DEX with what we now call the DEX. And we built a sort of multi-asset ledger. And then the way we conceptualized it was like, there were Bitcoin maximalists even back then that were like, Bitcoin is going to sort of take over the world. It's going to replace every payment system and everything will be great. But of course, if any payment system took over the world, everything would be great. Like if everybody used to say, it's like religion, right? Every religion's a religion of peace if everybody in the world believes the same religion. So it's kind of the same thing. Like they were like, Bitcoin will be great because everybody will use it. And then there'll be, but any payment system would be great for everybody. So we realized even if you believe that, you have to get there somehow. And the way to get there is you need a multi-asset ledger, because the value, even if you think Bitcoin, back in the day, even if you thought like Bitcoin was going to take over the world and everybody would use Bitcoin for everything, they still have to get there, right? 99.999% of the world's value isn't in Bitcoin then and isn't now. And so we had this idea that you could have a multi-asset ledger. And so the very first sort of pitch for the XRP ledger in mid-2012, when it was feature complete, was this idea that you could have public pools of liquidity that anybody could contribute to and draw off. So if you hold dollars and you want to pay somebody Bitcoin, or you hold XRP and you want to pay somebody ETH, you could sort of draw off other people who held one asset and wanted another. And so what we did in the XRP ledger is we built order books for people to say, hey, I have this asset, but I'd be willing to trade it for this asset. And then we built a payment engine with pathfinding and a multi-path execution engine. So people could say, hey, I owe Jeff $14. What is the most efficient way for me to make that payment? And then sometime in early to mid 2012, we had the XRP ledger feature complete with the same basic features around accounts, issued assets, XRP as a native asset, order books, DEX, that we have today.
Well, thank you for jumping right into it. At that time, did you start with an existing code base, or did you start from scratch?
Sorry, I couldn't quite hear the end of that.
Yeah. Let me get closer to the microphone. I have to make choices either be in the screen, or... Okay, so yes. One of the questions we had was, did you start from a blank sheet or did you start with an existing code base?
We started with Bitcoin. We kept but we didn't keep very much from Bitcoin. One of the main things, there's basically two things that we kept from Bitcoin. The base 58 account representation, because we liked the idea that we wanted accounts to be as short as they possibly could. And we kept the crypto exactly the same as Bitcoin for a very funny reason. We didn't want to deal with any argument that like Bitcoin was better, or that the crypto was better or worse, or that we didn't want to have to deal with defending the crypto decisions. And so we kept, we used SECP 256K1. We used the same Schnorr signature, not Schnorr signatures. We call them. We use the same signature as ECDS. What is it? Whatever. But we kept it the same. We thought we wanted to use other crypto algorithms. 25519 we thought was probably better, and we thought there were other options like the weird SHA hash followed by the MD160 hash we thought was a little weird, but we felt that it was better to not change anything that we didn't have a really good reason to change, just because we didn't want to have to, we didn't want to have to defend our decisions while we wanted the conversation to be about the core distinguishing factors and not a whole bunch of noise around little things. So we didn't change anything, at least initially, that we didn't feel like we had a good reason to change. Okay, plus, it was already done, so it's easier, right? It's easier not to change something than to change, right? We had the Bitcoin code, and so we had enough work to do that we didn't want to go changing things that didn't need to be changed.
So, what is it the explanation for the choice of C++ as a core language?
Well, I'm a C++ programmer. You know, that's so. I mean, if I'm the first programmer that you hire, you're going to get a C++. If it's a programming job, you're going to get a C++ result. I think also a driving factor was that Bitcoin was written in C++. I think if we had it to do over today, we probably would have chosen Rust, just because of the memory safety. But like, you know, there are a lot of advantages to C++. One is that the compiler technology is very mature. The tool chain is very mature. Platform support is spectacular. And I think today, though, Rust would probably be, if not, you know, probably just as good. And the advantage of memory safety is not. And there's a lot. You'd be surprised how many. Well, probably you wouldn't be, but like a lot of bugs and issues with C++ code circulate around. You know, come from its memory safety issues. So Rust has an edge there. The portability, obviously.
Yeah, you're already answering one of the questions that we had. If you had to do it differently today, so Rust would be one change. Is there any other thing that you would change?
Well, there's a couple things. Probably the biggest one, and I hold some guilt around this, is the issue with partial payments. So in a payment, so in Bitcoin, if you see the transaction and you know that it succeeded, there's nothing else that you really need to know. Because the UTXOs are very simple. In the XRP ledger world, if I make a payment, I might say, hey, I want to pay David Bachiri $30, and I'm willing to pay up to 10 XRP to do it. And here are some order books that you might want to use, but the payment engine makes a decision at runtime, because I don't know when I form the transaction exactly what the state of the ledger is going to be when the transaction executes for real. So I don't know which offers it's going to take. They may not even be on the ledger at the time I place it. I don't know exactly what exchange rate it's going to get, and so on. And so we have this thing called transaction metadata that's generated by the ledger itself after the transaction executes, that comes back and says, oh, here's how much it cost you, here's the offers it took, here's how much money it delivered, and here's all the other ledger changes it made. And you need that information to understand what the transaction did. So we have this thing in a payment. You can set a flag that says, hey, allow this payment to go through even if it doesn't deliver the maximum amount I want it to deliver. Normally, if I send a payment for $10, it's all or nothing. It's either going to deliver $10 or it's going to fail. And most of the time, that's what you want. You either, you know, if I'm buying something and it costs $10, I don't want to send them $9 and then have to send them the other dollar, then have to aggregate those payments together. Like it's not normally what I want. So normally I want either the $10 to be delivered or nothing. But I can set a flag in the payment to say, hey, even if this didn't deliver the amount I wanted, let the payment succeed anyway. And if you set that flag, there many times in the history of the XRP ledger, people had bugs in their code where if they saw the payment had succeeded, they just credited the amount that the payment attempted to pay without checking if it actually delivered. And worse, in the very early versions of the payment engine, it was extremely difficult to determine how much money was actually delivered as a result of the payment, because there wasn't an explicit field that gave the amount that the payment delivered. And that was a huge mistake, and that led to financial losses for people. And the interesting thing is, technically, there's really nothing wrong. It's just a failure to consider the human factors around it.
And so we have an echo.
Yep, someone's got my gun.
There
we go.
Yeah, we pulled in several cameras for you to get everyone in. It's just not possible. The room is too big. So we have C++ developers here who are spending 2 weeks of their lives to learn about the protocol. And so there's a lot of information that is exposed in the white paper. There's also some information that is not in the white paper that you have to dig the code to find about. Can you share with us a few Easter eggs that are hidden in the code, or the things that, last time we spoke, it was a few weeks after the halt, this time the XRP ledger was not able to make any forward progress for about an hour. And the explanation you gave me was definitely not in the white paper. So can you walk us through for instance, the consensus, how consensus is done from a code perspective?
Boy, I mean, it's I love walking through. I love walking through it, but it is very complicated, and there are a lot of quirks to it. I think one of the best ways to sort of understand it is to do the sort of I'm probably showing my age here, but there used to be this thing that would show on television called How a Bill Becomes a Law, and it would trace like a bill from someone having an idea for a change to the law all the way to it becoming the law and all the steps that it had to go through. And so I kind of like to think of consensus as sort of like how a bill it's like the how a bill becomes a law story. I want to form this transaction that does this thing. And then eventually it winds up in a fully validated ledger. And so like that journey, like following that journey is a good way to do it. So let's kind of walk through that journey mentally. So David decides that he wants to send me to XRP. So he forms the payment transaction, he signs it, he submits it to an XRP ledger server somewhere in the world. And that server, initially, when it receives the transaction, it looks at it and it says, first of all, is this valid? Is this actually a transaction, right? Someone claims it's a transaction, but is it one? Is it well formed? Does it, meet all the, can I understand what it is? And if not, it just throws it away, right? That's the most initial check. Then the next thing it does is it checks the crypto around it. Now, it doesn't necessarily know what, the account might not even exist, but it can check that the public key is in the transaction. So it can check that the signature is correct for the public key in the transaction. And if it doesn't pass those basic tests, no matter what the current ledger is, the transaction is invalid. So essentially, the first check is, could this transaction be valid in any does there exist some conceivable ledger in which this transaction could be valid? And if not, we just throw it on the floor as incoherent. Now, the next check that we need to do is to say, could this go in an actual, like actually looking at the current ledger? Does the account that the transaction comes from exist? Does it have enough XRP to pay the transaction fee? Is the sequence number in the past, in which case the transaction can't fit either in this ledger or in any future ledger? So the next question is like, can we reject it on the basis of it couldn't possibly go in this ledger or any subsequent ledger? So if the account doesn't exist, it could go in a future ledger where the account exists. Maybe we just didn't see the transaction that creates the account yet. So there's sort of the first bucket is, could it ever be valid? Then the next rejection is, it can't fit in the current ledger or any ledger after the current ledger. And again, we can just throw it away. Then the next one is like, can it actually go in the current ledger? Like, are we missing if it's sequence number 7 and we haven't seen the transaction with sequence 6 yet, it can't go in the current ledger. And then we'll hold it. But if it can go in the current ledger, then every server has what we call the current ledger, which is like its current view of all of the transactions that it thinks will likely go in the next ledger. And so we'll put it in the current ledger if it fits. If it doesn't fit because of fee or because the ledger is full, has too many transactions in it, then we put it in a hold. Now we have to wait until a consensus round occurs. And so each server independently makes the decision when to start a consensus round. And that's based on, well, first of all, if there's a consensus round currently in progress, we can't start a new one while one's currently in progress. If none's in progress, we have a 2-second time minimum. We make sure that there's at least one unconfirmed transaction. Otherwise, we'll wait a little bit more time. Then when we decide to start a consensus round, we take our current open ledger, the one that we put all the transactions we've been receiving in, we take its transaction set, and we say, this is the set of transactions that we think should go in the next ledger. So if while I'm running, I receive 10 valid transactions, they all fit in the ledger, I'll propose, if I'm a validator, I'll propose those 10 transactions. Now, it's important to understand that a server goes through this exact same logic, whether it's a validator or not. Of course, if it's not a validator, it doesn't send its proposals, it doesn't send validations, but it goes through all of the same mechanics itself. And in fact, if you're a validator and your proposals and validations don't get broadcast, you would never notice the difference. Like, assuming the rest of the network is healthy, like everything would, because if everybody in this room is trying to agree on, let's say everyone in this room is trying to agree on a number between 1 and 10. If you're gagged, you wouldn't notice. Because like if you're proposing a number that's unpopular, it wouldn't be surprising that other people didn't pick it up. And if you're proposing a number that's popular, other people are going to agree with it, even if they don't hear you. And so there's no distinction from the point of view of a validator or non-validator. The network appears to be behaving the same from their point of view. Of course, there have to be some validators to actually ever reach a consensus, because we actually do have to be doing some agreeing. So if you're a validator that's not being listened to, if you're not a validator, consensus works exactly the same from your point of view, as long as the network as a whole is healthy. So you you broadcast your initial proposal, which is what you think should go in the next ledger, uncontaminated by anybody else's view. There's a a chance to publish its initial proposal before anybody changes their position. Now, what we don't want is a situation where if there's close to a 50-50 split on a transaction, what you don't want is every time someone switches from no to yes, like I switch from no to yes, and then every time someone switches from yes to no, I switch from yes to no, because we're close to 50-50, and it gets very noisy. So there's a delay. I think it's 600 milliseconds. I think a server won't change its position more often than once every 600 milliseconds. And the idea is that 600 milliseconds is roughly enough time for a proposal to cross the network. So if I change my view from yes to no, and David changes his view from yes to no, hopefully people will get both of those changes and will aggregate into a single position change or no change. Now, if at any time from a server's point of view, there's 80% agreement, now this is an important thing. It's not 80% agreement with each other, it's 80% agreement with you. So if there's 80% agreement, but I'm not in that 80%, I don't declare a consensus. Now, there'd be no reason why that would ever happen, because if there's 80% agreement on any individual transaction, I'll switch to the position of that transaction. If there's 80% agreement on the set of all transactions, then there's no reason why I wouldn't agree. I guess the one exception would be if a transaction is formally invalid. If a transaction is like malformed, then I can never have that transaction, in which case, right, you should never go along with an invalid consensus. So at some point, as each server sees 80% agreement, it'll send a validation to the it'll broadcast a validation after it builds the ledger, and then it will potentially start the next consensus round. Now, as a sort of asynchronous separate process to that, so that's consensus, and that produces a stream of validations. That stream of validation does two things. Number one, if a server sees 80% validation for a particular ledger, it considers that ledger fully validated if the ledger is valid. So that's a sort of separate local decision. Just like in Bitcoin, I can decide that I want to wait for 10 confirmations, 6 confirmations, I can use any local rule I want to decide when I consider a Bitcoin transaction fully confirmed and irreversible. It has no effect on anybody else. That's a local decision. And so validations support that local decision of when to consider a ledger fully validated. And that's how we solve the Byzantine generals problem. We cannot make consensus perfect. There's a simple proof that consensus can always fail. If I remember, I'll go through it or remind me. And so we need this sort of, in the Byzantine generals problem, right, the two generals either try to both attack or both not attack, and there's no way to guarantee that. But the next day, they can go and look and see who attacked. And so validation is that sort of next day we look back, and if we did in fact agree, then we can consider a ledger to be fully validated. Now, another thing also happens. Because consensus can't be perfect, there's always a possibility that a server will get consensus wrong. But we don't want to assume that we got it wrong and go changing what we're doing, because if we got it right, we're critical to the progress of the network. So there's a monitoring where we use the stream of validations, and if we see that we definitely are wrong, then we can transition. So one example of us definitely being wrong is we're building Ledger 7, and we see full validations for a different Ledger 7 from 80%. We're definitely wrong. Like the network has moved on to Ledger 8. We're still working on consensus. We're definitely wrong. And so at that point, we want to abandon that consensus round and rejoin. So there's a monitoring process that every server uses based on watching the validations to say, hey, we got consensus wrong. We need to switch to another stream. And the net effect of this is if you watch the network as a whole, it's like a swarm of fish where all the servers are swimming together down the ledger stream. And every once in a while, one fish will be like, it'll be all the way up here. It'll be like, hey, guys, because someone has to be willing to swim that way, because the network might go as a whole. Someone has to go that way first. And if you go that way first and you look back and everybody else went this way, then you rejoin. And every server, we're leaderless symmetric. So everybody has to be willing to take that first step and then turn around and see if everybody else is following behind them. And if they're not, then sort of you can imagine there might be a ledger over here that sort of rejoins the stream a little bit later on. And I actually measured on the live network, about once every 2,000 ledgers, we had a meaningful disruption where we lost, like a typical server might split off the ledger stream like every 300 to 500 ledgers, and it'll just come right back, and it's no effect on the network. And about every 2,000 ledgers or so, we have a significant disruption where enough servers declare an early consensus that they have to reform, and the network is actually, has a hiccup in the ability of the network as a whole to produce full validations. And there's an interesting trade-off here. You can make consensus more reliable only by making it slower. And if you're going to produce, if 1 out of 2,000, you only have a network level disruption 1 out of every 2,000 ledgers, how much slower would you be willing to make every single ledger to reduce that even lower? And the answer is it's probably not worth it. And you can't reduce it to 0. You can't avoid the complexity because of the Byzantine generals problem. You can never make consensus 100% reliable. Somebody always has to, and here's the simple proof of that. Imagine there's 2 doors to the room you're in, right? And I challenge all of you to walk out the same door. Okay, there's 2 doors, and I say to you, I want all of you to walk out the same door. Okay. At some point, each one of you has to make, let's assume you're going to be successful and you're all going to walk out the same door. In order to succeed, at some point, every single one of you must irrevocably commit to one of the 2 doors to walk out of. At some point, every single one of you has to say, I'm going to go out the left door, and that's that, or I'm going to go out the right door, and that's that. Otherwise, you can't possibly win. That means, because we have no synchronous time based on the network, that means somebody has to commit to a door first. Somebody has to be the first person to say, I will only go out the left door. Let's say that's David Bichiri. When he commits, everybody else could still walk out the right door because he's the first one to commit. So somebody has to decide to walk out the left door, even though at the time they decide, everybody else still could walk out the right door. And that's the proof that consensus can never be 100% reliable. Somebody has to publish the first validation. Somebody has to irrevocably choose to publish some validation while everybody else could validate something else. There's nothing you can do about that. It's just the laws.
So,
it just comes from the fact that the network's asynchronous.
everything you just described, is it the original design, or did you empirically change things and fine-tune things along the way?
Everything that you just heard was the original, was the very, very early design. Now, did it work as well then as it does now? Did we have all the details implemented? No, but that was the very, very quick, like in the first version, the round time was like 30 minutes. So that's obviously a big difference. There were all kinds of big differences, but the logic, as I just walked you through, of how the network produces a stream actually, you know what? I think at first we thought that we could get consensus to be reliable enough that we didn't need validation as a second backlook process. Certainly laid a trap And there was one exchange that they wrote all the code, we audited it, everything was fine. And then they needed to add some new feature, and they had like an intern add the feature, and they reviewed the code themselves, but they didn't understand that there was a little bit of a minefield there. And on most other like on every other blockchain at the time, remember, this is like this was the first blockchain that wasn't basically a clone of Bitcoin. And in Bitcoin, all you need to do is, if you only see successful transactions, just looking at the transaction tells you everything you need to know about what it did. And we're not in that, like, we set a trap for people. But I don't believe there's ever been any attack on the blockchain. It's on the blockchain itself. There's never been a successful. We've had bugs that have caused, misbehavior, but nothing that caused a financial loss. I guess a halt. There could be some financial loss from a halt. Like, I suppose there's probably like some exchange probably lost some revenue due to the halt or something. But other than that, and the partial
Not directly on the protocol.
right, exactly. I don't believe so. Which is a great record. And one of the annoying things about, if you look at the pace of development slowed once real money became involved. The pace of development dropped drastically. And that's one of the downsides of having a live blockchain that has, multi-billion-dollar asset value on it. Development is necessarily slow, and feature changes. And that's a big problem for the XRP ledger, because in competing ecosystems like Ethereum or Solana, you can develop new smart contracts that provide new functionality very quickly. They don't need to be adopted as ledger level features. And today, because there's no real programmability on the XRP ledger, we have a great AMM, we have a fantastic DEX. But if you want to change it, if it doesn't do what you want and you need something else, you basically have to convince everybody to accept it as a new protocol level feature, which is necessarily slow. And I think that's the biggest disadvantage of the design that we settled on.
So thank you for that's a great segue for my next question. We have a book on our bookshelf here. It's called The Infinite Garden, and it tells the whole story of how Ethereum came to life. And it says there, I learned it from this book. It says there that the white paper was written while Vitalik Buterin was couch surfing in Stefan Thomas' living room a while ago, and that they had a lot of conversations around smart contracts. So at the time, Stefan was CTO. I don't know if it was already CTO at Ripple, but I can imagine that the idea of smart contracts, if it was already in the air, was discussed heavily in your team. What was the rationale behind not implementing smart contract at the time?
Yeah, you could imagine an alternative universe where Stefan was persuaded, and I was persuaded by Vitalik's argument that smart contracts belonged on layer one. And you could have an alternate universe where, like, we tried to hire Vitalik, but we couldn't for a hilarious reason. The company was less than 6 months old at the time, and you have to have been a company for 6 months to sponsor a visa in the United States. You can imagine an alternate timeline where, like, Vitalik convinces Stefan and I, we hire him, and think of all the great things Vitalik could have accomplished. Oh, sad. Yeah. So here was our thinking at the time. We thought that smart contracts didn't really belong on the layer one, because for a couple of reasons. So one is there are multiple. If a smart contract is on a layer one, it can only interact with that layer one, which is a huge limitation. So, like, if you build a smart contract on Ethereum, it can't even interact with Bitcoin. Like, that kind of sucks. Also, you're limited to the compute resources, the storage, the processing power, the language support of that layer one. And the big problem, and of course, the layer one can't keep a secret. Those are like huge disadvantages to building a smart, to building a smart contract at layer one. So our thinking was it made more sense to build this, and also every validator would have to execute, like, at least initially, every validator would have to execute every single smart contract as part of the block building, which would drive up the cost of running a server, would drive up transaction fees. And it seemed like you could write smart transactors that covered the vast majority of the interesting use cases. And so that was the reason that Stefan and I were not persuaded by Vitalik's argument. And we did work on various different techniques to build smart contracts that weren't tied to particular blockchains, at particular layer ones. And it turned out that was a lot harder than I think either of us thought it was going to be. Like we worked on what was it called, CodeES, and some other versions, some variations of CodeES. And the problem that the problem turns out to be that the trust model gets very complicated. Like if you could trust secure hardware, you know how modern processors have features like SGX that allow you to have the processor keep a secret from the user, and so in theory, you could put your secret key, you could transfer your secret key to my computer and I couldn't get it out, and it could only work on the code that you and I both agreed on in theory. But it turns out in practice, those security models don't work very well. And so I think Vitalik kind of had the better, well, certainly the value of Ethereum proved that, there was a market for smart contracts at layer one. But I think it's still sort of an unsolved problem of what if I want to deploy a smart contract that can keep a secret and that can interact with multiple layer ones? And I want it to be able to, pull web pages, and, like you can't do those things on Ethereum or on any current layer one. So I think there's still a need for a better way to execute smart contracts. We just don't really have it yet.
So working on multiple layer ones, there are two questions. One that's more historical, and I want to carry on that is, what was the rationale behind starting the interledger foundation? Because for me, my understanding is that it was the first step towards interoperability between blockchains. And what are the more recent choices and design? There are two different bridges that are being built, and more that are in the pipes. What's your take? What's your take on the interoperability as of today, and how did it start?
Well, so the theory behind interledger it's really interesting. I think it's an idea that was way ahead of its time. But let me tell you the way I explain the concept behind interledger. Imagine that you and I have some way we can settle funds. Maybe you trust me to owe you money. Maybe I already do owe you money. Maybe you owe me money. Maybe we both have accounts on the XRP ledger and we can move XRP around. And I like to hold XRP and David holds a whole bunch of XRP. Or we have some way we can settle. It doesn't matter what it is. And that's such that if somebody gives you money, I'll be willing to make an outbound payment for them. Or if someone gives me money, you'll be willing to make an outbound payment on any system that you have the ability to make it out. Maybe it's the Bitcoin blockchain, maybe it's the XRP ledger. It doesn't matter. It doesn't matter what it is. There's some way, because you and I have some relationship with each other, whatever that is. Maybe you're holding a bunch of my money already. Whatever it is, it doesn't matter. And I can make outbound payments on several different things, and I can make inbound payments on several different things, and so can you. So you and I can advertise the fact that we have this relationship. But I can say, hey, you can give David Bichiri XRP and I'll make a Bitcoin payment. Or you can give me XRP and I'll make a bit, whatever. We have some way to settle. Interledger is a system where people can advertise these settlement relationships. They can connect them together to form payment streams, and it uses cryptography to guarantee the results. And it doesn't require any trust that doesn't already exist. So, for example, suppose I'm willing to let you pay me by making David Bichiri owe me money. All right. If I want people to pay me, I have to have some way for people to pay me. There has to be some way that they can deliver money that I'll accept. And let's say that David Bichiri already owes me a bunch of money. So if you make him owe me money, it reduces his debt. Let's say I already owe a bunch of money. So you making him owe me money reduces my debt to him, right? And so if I trust him to be holding my money, then all you need is a signed statement from David Bichiri that you paid me. And that's just as good. Right? Like if my bank tells me that you paid me, that's just as good as paying me. Because if I tell you to pay me, if I tell you to send money to my bank account and my bank says you did, I can't then say, no, you didn't pay me. Right? And so it leverages the only existing trust relationships to make payments. And it doesn't care what the underlying method by which the funds are delivered is, as long as the relay points can support cryptography. So if you have somebody somewhere in the Interledger network who you trust to hold money on your behalf, that enables that person to provide cryptographic guarantees to everybody else, and that's all you need. And it does some incredible things. So, for example, it solves problems that are very difficult to solve. So, one problem that's very difficult to solve is what we call the free option problem. So, let's say I want to send, I owe David Vacheri $10. And someone says, hey, I'll make that payment for you for 3 XRP. I can wait, watch the price of XRP. And if it goes up, I don't take that offer. And if it goes down, I do. So you have to give me some time window in which that offer is valid. And so what you would want to do is either charge me for the quote, but then I might want to get 10 quotes and compare them. But if I'm paying for those 10 quotes, then I don't want to get 10 quotes. So you might make the quote only valid for a short period of time, but then I run the risk that I'll take the quote too late, and you'll just give me a shitty quote, so that even if the rate gets worse, you'll right. The free option problem is very painful. Interledger solves the free option problem because it allows you to break. It's the same way the internet solves the lost packet problem. You can break the payment into pieces that are so small it doesn't matter if they're lost, and you can investigate paths to see which paths are giving you the best rate, and then send more. You can actually stream money down the best paths. It's a really cool protocol, way ahead of its time. Wasn't very successful, as it turns out. I think part of it being because it's ahead of its time. So we're back to bridges, and bridges have sort of some fundamental problems. One fundamental problem with a bridge is bridges can't use the same trust model that layer ones use. Validators can't steal XRP because there's no place you can take it. You can't take XRP off the XRP ledger. There's like no way to get it out. And so if a validator found some way to make the XRP ledger say that they had all the XRP, everybody would be like, nice try, but no. Like, there's no conceivable way about even forgetting all the technical. Even imagine if all the technical protections fail, and I'm a validator, I somehow magically make the XRP ledger say I have all the XRP. Everybody's just going to be like, no, David, we'll go back to the last ledger before something terrible. Right? I wouldn't actually get the XRP out. And of course, you can't steal a stable coin. If I found some way to make the XRP ledger say that I had 1 billion RLUSD, Ripple would be like, oh, it sucks that we can't use the XRP ledger to track RLUSD now, but they're not going to give me the $1 billion. Right? We're not trusting validators not to steal money. We're trusting them not to break the network. Bridges have to be trusted not to steal money. And so one of the problems with that is if the bridge is making a lot of money, they're very incentivized to operate reliably because they want to continue their revenue stream. But if a bridge is making a lot of money, that means they're expensive. And so people will tend to evade the bridge, which will drive their revenues down, and people won't want to use the bridge because it's expensive. If the bridge is cheap, it's starting to look really attractive to do an exit scam and steal all the funds that the bridge is protecting. So it's very challenging to make secure and reliable bridges. And there's several different. Everybody in the industry is working on this problem. It's well understood. There's several best-in-class bridges that do their best to solve the problem. But I think still there's more work to be done. The other problem that you have with bridges is if you try to do things like use zero-knowledge proofs and other types of like cryptography to secure the bridge, you still wind up with the problem with like you built a nuclear reactor that has like a 0.01% chance of melting down. The zero-knowledge proofs, they have vulnerabilities where they can be wedged into a state in which they can't be advanced for data withholding. So you can get into a situation where nobody can produce a valid zero-knowledge proof because the system's wedged into an unknown state. And either you have somebody who can recover from that problem or you don't. If you have nobody who can recover from that problem, then everything's fine as long as the system doesn't break. But in the low probability chance that the system breaks, everybody loses all their money, which is pretty awful. Or you have somebody who can unwedge it if it breaks. But then the problem you have is, well, they can unwedge it if it hasn't broken and change the rules to steal money. And so you try to create these governance layers of like, you try to create somebody who's, who isn't necessary for a normal transaction, but has the ability to shoot down suspicious transactions. So you have this thing where like, if there's you try to create these like multiple layers of governance, and you have these like, okay, we have these people who can only prevent transactions, but what if they prevent transactions they shouldn't and demand them? So the other problem is, if I can prevent you from accessing your money, that's just as good as me being able to steal it. If I can prevent you from accessing $100,000, I can demand the $90,000 bribe to let you access your money. And so you think, well, we try to create these like governance entities that can freeze the bridge, but they could freeze the bridge and demand a fee to resume it. And yeah, everybody in the industry is working on this. The bridging problem is very well understood in the industry, and there's best-in-class bridge. I was very, very down on this. I was like, oh man, it was like whack-a-mole. Like every time we beat down a problem, another problem would pop up. I beat down a problem, another problem would pop up, and I was like, this is never. But then I started to realize the problems that were popping up were a lot less severe than the problems were beating down. And so it felt like it was actual progress. Like we went from somebody can steal all the money to like, we need a governance panel that's like, we need a governance panel that like has it, that could delay the funds, but not like it got better. But you're going to need governance is the problem that you're going to have. There's going to have to be revenue in order to maintain the operation of the bridge. They're going to be expensive because you're defending money from being stolen. You can't just adopt the same governance models that layer ones use. The other problem is when money's involved, it becomes competitive, right? Like if there's money to be made from the bridge, then I don't want you to get the money because I want to get it. And so you got all those, you've got to try to turn those factors in your favor. It's just challenging. The bridging is hard.
You mentioned something that made me think about one of the singularity of the XRP ledger is that it does not financially incentivize its validators. What was the conversation that led to that? And how is it still relevant today?
So two things. Number one, the cost to operate the ledger is not that high. It's like not that different from like DNS. It's not, right, because it's not proof of work. It's not proof of stake. There's no high cost to become a validator. And I think the other thing is that like, I like the idea of a ledger that like exists for the benefit of the people who use it to transact. Every other ledger seems to exist for the benefit of like some token holders. But like, if you're an exchange, you're not a token holder.
Yeah.
But you're the people who use the ledger. Like you build your business around it. And like, I feel like the transactors are the real stakeholders. I think there's room in the market for a blockchain where the transactors are the stakeholders. And the cost to produce blocks is low. The amount of trust extended is low. I agree, it's a different model, but you only need a small handful of validators. You don't need 100 validators, right? 8 is fine. Like the ledger will be a little bit more fragile, but it'll work. And that allows us to keep fees down. The weird thing is, though, I think one of the it's kind of one of the ironies is like, at least for me and a lot of other people, at Ripple and who worked on the XRP ledger, we really bought into the be your own bank, no middleman. But everybody who comes to the space is like, hey, how can I be somebody else's bank? How can I be a middleman and tax other people's transactions? Like, if you think about like every other ledger's DEX, there's somebody who owns that DEX and taxes it. There's some entity that's like taxing all the DEX transactions. There isn't on the XRP ledger. That in theory should be better for the people who use it. The problem is people want, like, they want the fees to be invisible. I mean, I don't know if you know the story with Salmon or the wallet, but like Witsa has tried to charge like even the most tiny fees, and people are just like, we don't want to pay for. And yet on every other chain, they're being taxed in a million ways internally, but it's not so visible to the user. It's like if I made a competitor to Gmail or Twitter that cost you some money, even if like it was more private, and even if like the actual cost to you was the same or lower, people want the fees like obscured and hidden. They want middlemen. They want a bank to tax their transactions rather than them paying, $2 a month to access a system. And so it's become difficult for people to make a profitable business precisely because you can't just be someone else's bank. You can't just be a middleman. Like you have to charge your customers for the services that you're providing them. And that's really hard to do. And I think that's another problem that we have in the XRP Ledger ecosystem. That it's in theory, like people should prefer the XRP Ledger's DEX because they're not being taxed. It's cheaper. Like you're not paying fees from the DEX itself. But that also means that there's nobody who really has an incentive to promote the DEX unless they can charge you for it like directly. And people just don't want to pay directly for things. They want the fees to be invisible. It's another bit of a challenge. I feel bad for people who want to build businesses on the XRP Ledger. They build on other platforms because those other platforms allow them to be somebody else's bank and be a middleman and tax other people's transactions. Like people don't. Like I know that when I use Twitter, like I'm paying with my privacy and I'm paying, but like people don't really care about that. They just want stuff and they want to feel like they're not paying for it. And
So we have about 10-15 more minutes. We can do an open mic and anyone can shoot questions if you have direct questions. It can be personal questions too. Yeah, come speak loud in the microphone, please.
This comes up quite a lot, David. If you don't want to answer it, that's fine. I just wanted to know when you first built Ripple D and it started working. Like, I'd really like to know if you can remember that date, because obviously we've lost that first history, and it's always something that I've been curious of. Thank you.
Yeah, you know, it's funny. I was not paying any attention to the live network at the time because they had built so many ledgers and they were temporary and they destroyed them and they were just using to demonstrate things. And when we actually had the live ledger stream, we didn't know that that was going to be the live ledger stream for some time after it was beta. There was just never a reason to start another ledger stream. And when we lost those 32,000 initial, we actually lost about 40,000. We recovered about 8,000 of them. When that happened, I just assumed that it would become irrelevant at the next restart. And then there never was another restart. And I would be a much richer person if I was paying more attention. Like there was still XRP in the Genesis account at the time that you could just take. There, you know, I could have just I was transacting on test networks, and in my point of view, like that network that became the live network was like the public test net. And I could test much faster on a private test net because I could throw it away. I was testing code changes. They were testing the previous, like last week's code. I was testing next week's code, right? So I was almost never interacting with what I thought of as the public test net. And then one day the public test net became like billions of dollars. And it's kind of funny that like, yeah, I mean, like I never even like asked. I don't even know. Like I only had an account on it. It's kind of funny. I created an account on it, and Jed funded me with 1 million XRP from the company's XRP just because that seemed like a nice round number. And that later turned out to be a significant amount of money. You know, and I'm like, wait, is that mine? You know, because like he gave it to me in my capacity as an employee, but it was like, did I just make, you know, the idea that it would be real money or that it would be important was just the furthest thing from my mind at the time. I want to point out something else too, which is like the idea that XRP could become like billions of dollars was, I mean, I'm sure there were people who would have said, yeah, we can imagine a world where like, but like, it was not a realistic possibility. Like when XRP hit a penny, like we were just like, wow, that's incredible. Like that's $1 billion for the whole thing. You know, like that was just mind blowing to us. It was literally worthless at the time. And even like, at least for me, and I think for a lot of us, even aspirationally, like when we were promoting the company to investors, we didn't say, hey, we're going to own 80% of the XRP and it's going to be worth billions of dollars. We said, look, we might be able to distribute the XRP in ways that allows us to fund ourselves. And we're going to be like the blockchain experts, and we'll carve out, you know, niches and opportunities. I at least, and I don't think anybody else did, certainly in our initial pitches, we certainly didn't propose XRP as like a significant source of revenue. Obviously, it turned out to be. And it's interesting that created problems for us that we didn't foresee. So for example, we used to just give XRP away. And when the only thing you could do with XRP was perform transactions on the XRP ledger, that worked really well. But then as soon as it had a price, if we're giving away $5 worth of XRP, someone will pay $4.50 to game the giveaway. And it was a good problem to have, but it very quickly became difficult to impossible to like give XRP away and operate the company. And it's still kind of challenging for us today because we don't want to hold as much XRP as we do, but there's not much we can do about it. I guess it's a good problem to have because like it preserves future value. But it's weird. We found ourselves in a very weird situation. I remember the day that like XRP hit a penny, and we're suddenly like Ripple's like holding like $1 billion worth of XRP, and we had to kind of like, it was a real weird because like we didn't have security around, like when we had some security, but not much because it was literally worthless. And it's just weird to have something literally worthless suddenly be worth $1 billion. It was a strange day over at Ripple.
Other questions? Yeah. Come forward.
You mentioned that if you had to restart from scratch, you would do it in Rust. So why not re-implement it in Rust today?
You know, there's people who there's definitely talk about doing that, and there's also been talk about modularizing the transaction engine so that the transaction engine could execute in a VM. and then you could implement because the transaction engine, having multiple implementations of the transaction engine would be very challenging. So you can imagine a situation where the transaction engine is sort of sort of compartmentalized and runs in a VM. And then maybe like the code around it that does the overlay and the database and the client queries could then be written in any language. It could be modular. We would like to have the code be more modular. It's kind of annoying that you have a monolith that has the consensus engine, the transaction engine, and client queries like all monolithically. That would be great. The big challenge is the certain bits of the transaction engine, particularly the payment engine, are not well enough specified that you can have. So another possibility is like, let's specify how that payment engine actually works. And if we wind up with a situation where we can't specify it, let's fix it. So one example of where you might be unable to specify the payment engine is we use something like floating point, imprecise math, and some of the numbers. And the net result of that is if you do like A plus B minus C, you can get a different result from A minus C plus B because of the precision. And there may be cases where like we have to sum up a bunch of stuff and we just do it and subtract and add the things and we just do it in a random order, just the code does in the order it happens to do it. And so if you try to specify it to produce the exact same result in another language, you need to execute those operations in exactly the same order. And if we picked an order that the code just happens to use that is illogical, it would be like you could actually specify, yeah, actually you have to do like Z minus Q plus T minus R plus, right? Like that would be annoying. We would probably want to respecify and have an amendment where at one time we switch over to a more organized, clear, coherent version of that code. And that would be a plus that would be a win all around. But even if we can't do that, we could isolate the pieces of code that have those annoying quirks, like the payment engine, and maybe modularize them into a VM or something so that you could at least have different implementations or other languages for pieces like the overlay. If you're interested in that, you should talk to, I think, Anshal Malhotra at Ripple. She is, we've actually got some proposals from some companies to do some of those pieces. And we're making decisions now about what we think is worth doing and what the order of doing things would be. But it would be nice. They've also talked about like having formal specifications for all of the various transactors, which would make it easier to have multiple implementations of them. So yeah, I definitely think that'd be a good thing. It's just not easy at all.
Okay. Other questions? So I have another question.
No, it's fine.
What would be your recommendation for the people in the room to start their journey as contributors? Where should they start? Should they focus their attention and energy on? Is it building a new amendment, documenting the code, doing starting with testing things? Where does the community need more muscles?
I guess it comes down to what people, what your skill set is and what you want to contribute to. I think a big thing, I think the biggest thing that's missing is stuff built on the ledger. Like, for example, it's still pretty difficult to provide liquidity to AMMs. It's still pretty difficult. They're still interacting with the ledger is still pretty difficult. As far as the core goes, the price of admission is so hard to modify code, like for a public layer one. I think you kind of have to start with like improving documentation or cleaning up existing code. It's such we've been looking for ways to make it simpler. One of the things that would be nice is to modularize some of the code so that it is more maintainable. But unfortunately, right now, like it is pretty difficult to contribute to the ledger itself. Like the price of admission is pretty high. There's a lot of areas where it could be improved. Memory usage is really bad right now. We've been working on that. There's still some low-hanging fruit. We have a lot of redundant caching in the code, but like again, the price of admission to get to that is really high. I would say probably like cut your teeth building things around the ledger, finding interesting use cases, but it's tough. It's the biggest. I have to say, it's one of the things that challenges me the most is when people say like, "What should I do?" and I don't have good, crisp answers for them. I think we need to come up with a better way to track what on two levels. One is what needs to be done, things that need improvement, and then opportunities for people who want to do things. I don't think we really know yet. I don't. Yeah.
We'll figure out.
With that question.
Yeah, we still have 10 days to go with training, and
I got to get in one joke before we run out of time, though.
Oh yeah.
I got to get in one joke. So a programmer walks into a bar. He says, "I'd like 1.2 root beers, please." The bartender says, "Oh, that's a float. I'm going to have to charge you extra." The guy says, "Well, then you might as well make it a double."
It's a
All
good
right,
one.
there's your joke. Yeah.
Thank you so much, David. We're really lucky to have you as a role model in the developer community. And I want to emphasize how available David is. If you have a question, I think the best way to reach you is Quora. I think you're still one of the top contributors. I would-
Twitter, email.
Yeah, you can funnel your questions through us, and we'll make sure that they get them.
Always happy to answer questions. And I think 50% of my job at Ripple is on the repository of why we did things a particular way. And it's funny, people be like, "Hey, David, why did you blah, 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 we should do blah, blah." And half the time it's, "Oh, no, don't change that. Here's why." Or on the other half of the time, it's, "Yeah, that was a bad idea. Please change that." But I'm the repository of which of those two buckets of things. I think the biggest regret, I think, is the math that we adopted our own version of floating of decimal floating point. It has its advantages, and you can understand the reason why. And some of the data representation choices we made, they were very optimized for our use case, but also very non-standard. And I have to say, I underweighted the importance of doing something that's standard, well-known, and well understood versus microscopically optimizing something for your exact use case. I erred in the direction of microscopically optimizing things for my use cases. There was a guy who his name is Kimon. I think his last name is like Papahajopoulos. He's a friend of Arthur Brito's, and he was looking at some of my code. He was saying, "David, I want to spend an hour with you. I want to teach you how to work much more slowly, but such that there's a chance that somebody else can understand what you did." And it was super valuable. I spent about 2 hours with him, and he went over some decisions I made and stuff. And he's like, "Look, I understand why you did that, but like, this other decision would not have been quite as good, but the net result would have been that you would have had something that would have been more maintainable." But of course, at the time, the least of my thoughts was, how will this hold up over the next decade, right? Because like at the time, it was like you jumped out of an airplane with hoping you have everything you need to make a parachute, because like you have a certain amount of time, you have very little money, you have only so much credibility, you only have an office for another 2 months, and we had to get things working, and half the time we would build things and throw them out because they weren't the right thing. So you don't want to build something fantastically, and they're like, "Oh, actually, we should have built this other thing." Throw that out, and you spent 12 hours perfecting it. And if you look at the early GitHub, the GitHub repository is public. You can look at the early stages where like Arthur and I committed multiple times a day, and we were basically using the GitHub like email. We never we left. It's all there, so you can see how rapid our progress was in early 2012. It was crazy.
Yeah,
Well, it was great talking to you guys. Thank you so much.
We appreciate you. Thanks for your time.
I had a lot of fun. I'm always happy to do it. Bye, guys.